Good morning, students. So now we are going to discuss about limitations of Ohm's law and drift velocity. So students, in our previous lecture we have discussed about Ohm's law. What is Ohm's law? So in a conductor, the current is directly proportional to the potential difference, and I is equal to V upon R, where R is a constant and that is resistance, and this should be kept constant. And we draw a graph, VI graph, and the status of graph was, suppose in the x-axis I have taken potential, in the y-axis I have taken current. So this should be the slope of graph. Okay, and this is resistance and should be constant for any value of potential difference. Okay, and this is known as graph, VI graph for ohmic conductor. Why I am saying ohmic conductor? Because the conductors which are obeying the Ohm's law, which follow the Ohm's law, are coming under the category of ohmic conductor. And there are not all conductors which are following Ohm's law. There can be a VI graph in such a way that for initial, for the beginning, it is following the straight line, and later on this is turning like this. Okay, so these are non-ohmic conductors. The kind of materials which do not follow Ohm's law are coming under the category of non-ohmic conductors. So this is the VI graph for non-ohmic conductors. Okay. So why this happens, or what is the reason that this is why we study the limitation of Ohm's law. That Ohm's law is not applicable for every condition. Okay, this is working up to a certain extent, and then we will get that the resistance is not constant. Resistance is constant here for every value. That's why these are ohmic conductors. But resistance is not constant for each and every value. That's why these are non-ohmic conductors. Okay, or non-ohmic materials. So, what can be the reason, or what are the points which we have to remember while we have non-ohmic conductors? So the very first point is in the limitation of Ohm's law that the graph between I and V can vary non-linearly. That's the first point. Okay, there is no necessary that the graph will remain a straight line. So non-linearly there should be. Okay, and there is one more condition which can be applied. The nature of the graph, depends on sign of potential difference. Even the sign of the potential difference are also getting better here. Okay, so what is the sign of potential difference? And what are these non-ohmic conductors? Means we should have an example. So I am writing the examples. Diodes you will study in semiconductor devices. So these are actually switching elements. In detail you will study in the next book, second book. Okay, diodes are the example, even vacuum tubes. So these are coming under the category of these non-ohmic conductors. So these are the limitations of Ohm's law. I hope you understood this. Now we are going to cover drift velocity. So students, drift velocity. Suppose we have a conductor. Okay, let me draw a conductor. So this conductor is of cylindrical shape. Okay, suppose the length of the conductor is L, cross section area suppose is A, and inside the conductor, what is the condition inside a conductor? So in a conductor there are number of electrons which are moving in a random direction in the absence of potential difference. So these electrons are moving in the random direction. Suppose I have applied the potential difference. So how I will apply the potential difference? The answer is by joining it to the battery. So suppose there is a battery, combination of cell, ion. Okay. Now students, when I will join it by the battery, this is the high terminal, so here will become a higher potential. This is of low potential, so this will become a low potential. And we know whenever there is a high potential and a low potential, an electric field is developed, so the direction of electric field will be from the higher to the lower. So this is the direction of electric field. In the absence of this electric field, the electrons were in the thermal generation and they were moving in a random direction and the energy they were getting by thermal energy. But the net movement of the electron was zero. So the net average velocity of the electron was zero. One electron may move in a random direction, another electron may move in a random direction, but if you will calculate the average velocity, that will be zero. Because they will collide with each other and they will cancel out each other's effect. Now students, the picture is different. We have applied the potential. Because of the potential, electric field has been developed. Suppose the length of this cylindrical conductor is L. So now students, what will be the drift velocity? What will be the condition? Let us understand. So we already know there is a high potential, there are electrons. The electrons will be drifted towards this positive end. So this electron earlier, which was moving in random direction, have got a specific direction. This electron will move in this direction. Another electron will move in this direction. This electron also will move in this direction, and so on. So earlier, due to the thermal motion, the electrons were moving in a random direction. Now the electrons have got a specific direction. So all these electrons are moving in a specific direction. And because of the movement of electron, there will be a origination of current. Okay. Now students, the average velocity of electrons against the applied electric field. So students, if you see the motion of these electrons, electric field is applied from the, this is left from right, left to right, okay, and movement of electron is in the opposite direction of applied field. So the net velocity, the net thermal velocity of electron in the opposite direction of applied electric field is known as drift velocity. Okay, now what is the electric field we have applied? We have studied one formula that E is equal to, what is the formula? We have studied. Electric field is negative potential gradient, so E is equal to V upon L. Potential is V suppose, and length of this is L, so electric field will be V upon L. Now, when these electrons are moving, why these electrons are moving? Because when a charge is kept in electric field, it experiences a force. What is the force experienced by this electron? So the answer is the force experienced by the electron. What is the formula for force? F is equal to Q into E. If E is the electric field, Q is the charge which we have kept. So the force experienced by the charge will be Q into E. Here the force experienced by these electrons will be minus E, because these are moving in the opposite direction of field, into E. So this is the force experienced by each electron. Now students, what is the acceleration? What is the acceleration of these electrons? We have studied the second law of motion. By this, A is equal to F upon M. So F is minus E upon M will be the acceleration of the electrons. So students, let us solve it further. Let us consider one electron. And one more thing which I wanted to cover out, that when these electrons will be drifted in the opposite direction of field, they will collide with each other. And between two successive collisions, there will be a time when the electron will travel. For example, this electron is drifting and another electron is drifting, both collide. And before collision, they will travel. And again, before collision, they will travel a distance. So the time when the electrons will travel a certain distance is known as relaxation time. Now, the word relaxation is not very dissimilar to its meaning. Relaxation means that taking the rest, but here relaxation time is the duration when the electron is actually traveling. And during the relaxation time only the electron will travel, and unless the electrons will collide with each other. So that is relaxation time. Acceleration we have calculated for one electron. Now let us consider one electron. Let u1 be initial velocity of one electron, initial velocity, and t1 be the time. t1 is the time when it will travel. t1 be the time. So what will be the final velocity gained by one electron? Okay, so v1 is equal to, we have studied the equation of motion. So v1 is equal to u1 plus at1. Similarly, there are number of electrons. So for second electron, v2 is equal to u2 plus at2. For similarly, vn is equal to, for nth electron, un plus at. So this will be the velocity. Now, what is the average velocity? Suppose we calculate the average velocity. So average velocity will be sum of observation. So v1 plus v2 plus up to vn divided by how many electrons are there? We have considered n. So v1 plus v2 plus vn up to n. Now students, okay, let us erase this so that we will get the proper space to solve. Now let us substitute the value. Average velocity we have calculated. So this will be like, in place of v1, there will be u1 plus at1 plus u2 plus at2 plus up to un plus atn divided by n. Now u1, u2 up to un you consider in one bracket, okay, divided by n, plus this will be a if you take common, t1 plus t2 up to tn divided by n. Now students, this is the average velocity. Now tell me, what is the value of this u1 plus u2? This is the initial velocity of electron, the initial average velocity of electron in the absence of field. So in the absence of field, as I have told you, the net movement was 0. So the net average velocity will be how much? 0. So this will be 0 plus a. Now t1 plus t2. T1 is the relaxation time of one electron, T2 is the relaxation time of second electron, Tn is the relaxation time of nth electron. So this is the average relaxation time, and this is denoted by tau, average relaxation time. I am giving it a special symbol, say tau. So this will be the average velocity. This average velocity I will denote by Vt. Okay, and this is drift velocity. This is what I have written. The average velocity of electron against the applied electric field. So this we will denote by Vd, as this is drift velocity. So Vd is equal to 0 plus a tau, or Vd is equal to a tau. Now students, we already have calculated the value of acceleration. So let us substitute the value of acceleration. Here is the value of acceleration. This is minus E upon m. So when we will substitute this, Vd is equal to a. In place of a, this will be minus E tau upon m, and this is the final relation for drift velocity. Vd is equal to minus E tau upon m. So this should be learned to you. Okay, I hope you understood this derivation as well as the limitation of Ohm's law. Thank you for this.